Okay, good morning to all of you. So we are going to start the next topic, differentiability. ये आपने already last year इसका शुरुआत किया है. So the basic principle was first principle method. It is like derivative of a function at a point. F dash x derivative is equal to limit h goes to 0 f of x plus h minus f of x divided by h. This principle, this is known as, this method, finding derivative using this method is known as first principle method. First principle method. One second. First principle method. तो इसका geometrical meaning मैंने उसी फर्स्ट दिन बोला था, इट इज द डेरिवेटिव. डेरिवेटिव मतलब इट इज slope of the tangent. It is geometrical meaning. Is slope of the tangent. Slope of the tangent. So उसका डेफिनेशन भी क्यों मैं ऐसे आ रहे हैं वो सब मैंने बताया था, फर्स्ट भी एक बार जल्दी बताऊंगा. मान लीजिए आपके पास एक कोई भी कर्व ऐसे है. So suppose here is the point x. Let the point here is x plus h. I hope you can hear me. Is my voice audible?
Yes, sir.
Okay.
Yes.
So,
Sir.
yes. So that point, this point, this is your function y is equal to, this is your point y is equal to, function is y is equal to f of x. So ये point होगा x comma f of x. Here आपका next point होगा, this is x plus h. x plus h में function का value f of x plus h. So that point is x plus h comma f of x plus h. So you can join those two lines. So this line is known as the, this particular line, this is known as the, it is known as the secant line. इसको बोलते हैं secant line बोलते हैं. So f of x plus h, f of x plus h minus f of x divided by, देखो x plus h minus x, so x cancel हो जाएगा, it is h हो जाएगा. So that is change in y. This is nothing but this is change in y over change in x. That means y2 minus y1 or x2 minus x1 divided by x2 minus x1. So that is nothing but it is the slope of जो मैंने ड्रॉ किया सीकन लाइन का स्लोप है. अभी as x approach, so if you give the points as name, you can give this point is say some a, this point is say some b. Now as h goes to 0, h 0 बन जाएगा, b will come close to a. So you can see that at the next, if it is a little bit close, then the secant line will be like this. और then again थोड़ा और क्लोज है तो और थोड़ा क्लोज आएगा तो ऐसे आएगा, और क्लोज आएंगे तो ऐसे आएगा. तो ऐसे आके आके at the last moment the secant line becomes the tangent line. It will become the tangent line at x. That will happen when as h goes to 0, the point b, it will come closer and closer. These points will h goes to 0 मतलब x plus h x में आएगा. That means the point b will be closer and closer to a. So secant line, you can see that step by step, last moment में when it is very close, h is very close to 0, point a and b becomes almost the same. That means the secant line becomes the tangent line. That means that is why limit of that thing, f of x plus h minus f of x divided by h ka limit when h approaches to 0, that is known as slope of the tangent, and slope of the tangent that is known as the derivative. That is why derivative ka geometrical meaning is slope of the tangent. So this is what you have studied as last class, means last year. Then you have seen the derivative of many functions using this standard results. You have studied many, for example, derivative. Derivative can be denoted using the letter d by dx, नहीं तो y dash, नहीं तो f dash x. I'm telling the main points only. Or d dash x. ऐसे many symbols are there to represent derivative dy by dx. Then we have seen, or we have derived many formulas like derivative of x to the power n is equal to n into x to the power n minus 1. This is the standard results you have discussed. Then derivative of, so इसमें से हमें और extra result मिला था, derivative of 1 by x is equal to minus 1 by x square. Derivative of root x is x to the power 1 by 2. Then वो formula apply करेंगे तो आपको मिलेगा 1 by 2 root x. These are all standard results. Then you have seen trigonometry function ka derivative of sin x. Derivative of sin x is cos x. Derivative of cos x is equal to
minus sin x.
Derivative of tan x is equal to 6 square x. Derivative of cosecant x, that is equal to minus cosecant x into cotangent x, derivative of secant x, that is equals secant x into tan x, derivative of cotangent x is equal to minus cosecant square x. So these are the results you have seen last year. Then again, you have seen some um, algebra like u and v are u comma v. These are functions of x, functions of x. Then u plus v का derivative is equal to derivative of first function plus derivative of second function. If it is u minus v का derivative of the derivative of first function minus derivative of second function, then u into v product of two functions उसका derivative. So product of two functional derivative, it is not the product of the derivatives. It is in every step you have to find the derivative of one function. Derivative of first into second plus first into derivative of second. And this can be extended to any number of functions like u into v into w. Uska derivative. So in every step you find the derivative of one function u dash into v into w plus u into derivative of v into w plus u into v into derivative of w, like this. This can be extended to any number of things, any number of functions. Then this is also known as, this is known as product rule बोलते हैं इसको, product rule, product rule. Now u upon v, derivative of a quotient, it is equal to denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. So आपको ऐसे पढ़ाई करना है, ऐसे u v के टर्म से अच्छा है कि ऐसे पढ़ाई करना है कि denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator का square. You have to study like that. Then another thing is derivative of a constant is equal to 0, where c is a constant. C is a constant. Derivative of a constant is equal to 0. But limit of a constant is constant itself. And derivative of a constant into function, which is equal to, you can take the constant outside, constant into derivative of that function. So these many things we have studied last year. Now, again, if you want to say a function is said to be differentiable at x is equal to a, एक पॉइंट में डिफरेंशिएबल है करके बोलना है तो जैसे लिमिट जैसे the left hand derivative and right hand derivative exist, and if left hand derivative or right hand derivative exists and both are equal. So left hand derivative exists होना चाहिए, right hand derivative exists होना चाहिए and दोनों equal भी होना चाहिए. Just hold one moment. Okay. So a function is said to be differentiable at x is equal to a if the left hand derivative and right hand derivative exist and both are equal. So left hand derivative, I will tell you the formula directly. So I don't want to go to the theory, all those things. जैसे आप मेनी टेक्स्ट बुक आप अलग अलग गाइड देखेंगे तो अलग अलग टेक्निक से निकाल रहे होगा बट सबसे बेस्ट फॉर्मूला है दैट आई एम गोइंग टू टेल यू जस्ट कीप दैट फॉर्मूला with you always and use that formula. So if you want to find the left hand derivative at x is equal to a, it is limit, ये formula apply कर देना, limit h goes to 0 f of a plus a, sorry, f of a minus h, left hand derivative है. So f of a minus h minus f of a divided by h. If you want to find the right hand derivative at x is equal to a, the formula is limit h goes to 0. By heart this formula, f of either, so ऊपर minus h है, either f of a plus h minus f of a divided by h. This is one of the most important formulas to find the left hand derivative because कभी कभी वो फॉर्मूला हमें जरूरत पड़ेगा क्योंकि क्वेश्चन में बोलेगा जैसे लिमिट जैसे बोलेगा फंक्शन सम x इज इक्वल टू 3 में डिफरेंशिएबल है ऐसे तो k का वैल्यू निकालो ऐसे क्वेश्चन जैसे लिमिट का क्वेश्चन किया था फंक्शन x इज इक्वल टू 3 में कंटिन्यूअस है ऐसे कंटिन्यूअस है तो k का वैल्यू निकालो ऐसे ही डेरिवेटिव में भी क्वेश्चन आएगा फंक्शन इज डिफरेंशिएबल एट x इज इक्वल टू सम 3 और x इज इक्वल टू सम 5 फाइंड द वैल्यू ऑफ k सो एट दैट टाइम यू हैव टू फाइंड लेफ्ट हैंड डेरिवेटिव यू हैव टू फाइंड राइट हैंड डेरिवेटिव उधर कोई स्टैंडर्ड फॉर्मूला काम नहीं करेगा लेफ्ट हैंड डेरिवेटिव निकालना राइट हैंड डेरिवेटिव निकालना and both values are equal karna. So this is the formula. So this is one of the important formulas. So इधर इतना है कि लेफ्ट हैंड डेरिवेटिव है तो इधर f of a minus h है इधर minus h है राइट हैंड डेरिवेटिव है तो इधर f of a plus h है इधर plus h है that's all the difference. Now before go into more problems, I want to tell you one more theory part. So what is the relation between the differentiability and continuity? How they're related? That is what I want to tell you. See, suppose f is differentiable at x is equal to c. So डेरिवेटिव्स का फॉर्मूला डिफरेंट तरीके से बता सकते हैं जैसे इधर आपको मैं बताता हूँ. So this is your point c, this is your any point x. So इधर c में फंक्शन का वैल्यू होगा c कॉमा f of c. इसमें से होगा x कॉमा f of x. तो सबसे पहले स्लोप ऑफ द टेंजेंट ड्रॉ करेंगे तो और सेकंड लाइन ड्रॉ करेंगे तो दिस इज द सेकंड लाइन. So f of x minus f of c divided by x minus c. So this is the slope of the secant line. Then when x approaches to c, limit x is approaching to c, the tangent line becomes the secant line at c, and that is a derivative at c. So this is f dash c. So we can say like this, f is differentiable at c, मतलब c में function के लिए tangent है, उस tangent का slope है f dash c. So f of x minus f of c divided by x minus c, change in y over change in x, that is the slope of the secant line. But when this x is approaching to c, last the secant line becomes the tangent line at x is equal to c. That is why slope of the tangent at x is equal to c, f dash c, or derivative at x is equal to c, f dash c is equal to limit of f of x minus f of c divided by x minus c. Okay, so सपोज हमने अस्यूम किया, f is differentiable, function is differentiable. Now we know that but x is not equal to c, because x is approaching to c, x is very close to c, just say 2 and 2.000001, like that, it is very close to c. So हम ऐसे लिख सकते हैं कि f of x minus f of c को हम ऐसे लिख सकते हैं f of x minus f of c divided by, मैंने x minus c से मल्टीप्लाई किया क्योंकि x is approaching to c only, x is not equal to c, x is approaching to c only, x is not equal to c, so x minus c is not 0, so x minus c एक नॉन जीरो नंबर से मैंने ऊपर नीचे मल्टीप्लाई किया, कोई फर्क नहीं, वो कैंसिल हो जाएगा. So therefore दोनों साइड में लिमिट ले लो, लिमिट ऑफ f of x minus f of c as x approaches to c should be same as limit of that complete thing, f of x minus f of c divided by x minus c into x minus c as ax approaching to c. So दोनों साइड लिमिट ले लिया. So right side में अभी limit of a product is the product of the limits. So I can write this as limit of f of x minus f of c divided by x minus c as x approaches to c into limit of x minus c as x approaches to c. And this is equals, this is nothing but limit of f of x minus f of c divided by x minus c as x approaches c is your f dash c. So that is your f dash c into, as x goes to 0, as x goes to c, this will become c minus c, this will goes to c minus c, that is 0. That means it is f dash c into 0. That means you are getting 0. So what you got is limit of f of x minus f of c as x approaches to c is equal to 0. Abhi, limit of a difference is a difference of the limit. So you can write this as limit of f of x as x approaches to c minus limit of f of c as x approaches to c is equal to 0. That means limit of f of x as x approaches to c minus f of c is a constant, it's the value of the function at the point c. So limit of a constant is constant itself, so it is f of c itself is equal to 0. Or you can say that implies, you can say limit of f of x as x approaches to c is equal to f of c. And that is nothing but that's a definition of continuity. Limit of a function as x approaches to c exists, and that is equal to the value of the function at c. That means f of x is continuous at x इज इक्वल टू सी. हमने शुरुआत किया था फंक्शन इज डिफरेंशिएबल एट सी. सो इफ अ फंक्शन इज डिफरेंशिएबल एट सी देन इट इज कंटिन्यूअस. उसका मतलब यही है कि every differentiable function, every differentiable function, every differentiable function is continuous. That means differentiability implies differentiability implies continuity. That means every differentiable function is continuous. So याद रखने के लिए और इस टेक्निक है ए बी सी डी, याद रख देना. सो एक बच्चा बोल रहे मुझे ए बी सी डी तक आते हैं, तो इनको डी तक आते हैं तो उनको पक्का सी पता हो जाएगा. दैट मीन्स इफ ही नोस डी ही नोस सी ऑल्सो. दैट मीन्स डिफरेंशिएबल है तो कंटिन्यूस है. बट इसका रिवर्स, कंटिन्यूस है तो डिफरेंशिएबल है क्या नहीं. So this is a relation between differentiability and continuity. If a function is differentiable, it is continuous. Every differentiable function is continuous. Now we will see about इसका रिवर्स कैसे है. कंटिन्यूअस है तो डिफरेंशिएबल हो गया है क्या. से फॉर वन एग्जांपल देखो. So we know that function, one standard function, that is mod x. Mod x का ग्राफ हमें पता है. It's a V-shaped graph. Suppose this is your function y is equal to mod x. So mod x मतलब जब कंटिन्यूटी और डिफरेंशिएबिलिटी जब प्रॉब्लम करते हैं, mod x जैसे लिखेंगे तो हम प्रॉब्लम नहीं कर सकते. उसको मॉडुलस सिंबल निकाल देना. mod x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. ठीक है. Now I'm going to check the differentiability at x is equal to 0. So I'm going to find the left hand derivative. Left hand derivative formula is, मैंने आपको बोला था, limit h goes to 0 f of a minus h minus f of a divided by minus h. So limit h goes to 0. So either your a is 0, we are checking at 0. F of 0 minus h minus f of a divided by f of a, where f of a is 0 here, so f of a divided by minus h. So that is limit h goes to 0 f of minus h minus f of 0 divided by minus h. That is limit h goes to 0 f of minus h. F of x is equal to mod x. Just 1 second. ഇവിടെ ഒരു 5 മിനിറ്റ് ഞാനിപ്പോൾ വിളിക്കാം. 5 മിനിറ്റാ ജോബിനെ, ഒരു 5 മിനിറ്റ്. f of x is equal to mod x. So f of minus h मतलब modulus of minus h is h. So आपको h f of 0 मतलब modulus of 0 which is equal to 0. So that is h divided by minus h. That is a limit of minus 1 as x approaches to 0, which is equal to minus 1. So left hand derivative is minus 1. अभी right hand derivative देखो. Right hand derivative limit of f of a plus h minus f of a divided by h as h goes to 0, which is equal to limit f of 0 plus h minus f of 0 divided by h as h goes to 0. That implies limit f of 0 plus h मतलब f of h. F of h मैंने f of h is mod x, that is h, minus f of 0 is modulus of 0 is 0 divided by h as h goes to 0. That is a limit of 1. That is, it is 1. Limit of a constant is 1. You can see that left hand derivative exists, right hand derivative exists, but both are not equal. That implies f of x is not differentiable at x is equal to 0. But mod x is continuous at x is equal to 0 because there is no break in the graph. ग्राफ में कोई ब्रेक नहीं है, सो इट इज कंटिन्यूस है, बट नहीं है तो आप लेफ्ट हैंड लिमिट राइट हैंड लिमिट निकाल के भी प्रूफ कर सकते हैं कंटिन्यूस है करके, बट सिंपल वे बताएंगे तो देयर इज नो ब्रेक इन द ग्राफ, सो इट इज कंटिन्यूस. सो दैट मीन्स continuity does not imply डिफरेंशियबिलिटी. ऐसे नहीं कंटिन्यूस है तो डिफरेंशियबल नहीं है करके नहीं, बट कंटिन्यूस है तो डिफरेंशियबल है करके कोई गारंटी नहीं है. बहुत सारे फंक्शन है कंटिन्यूस भी है डिफरेंशियबल भी है, बट इन जनरल कंटिन्यूटी डज नॉट इम्प्लाइज डिफरेंशियबिलिटी. That means every differentiable function is continuous, but the reverse is not true. Every continuous function is not differentiable. This is the mod x is an example, and I will tell you one more thing where it is not. जो sharp edge, sharp turn है जैसे v, so sharp turn आ गया, so उसी point में that जो उसी point में continuous नहीं है, इसलिए नहीं है कि उधर सॉरी उसी पॉइंट में डिफरेंशियबल नहीं है, डेरिवेटिव नहीं है, इसलिए नहीं है कि उसी पॉइंट में यूनिक टैंजेंट नहीं है. आप उधर एक आपका जो फिंगर ऐसे क्रॉस रखने के बाद उसके ऊपर एक पेन रखेंगे तो कैसे भी मूव कर सकते हैं. दैट आई विल एक्सप्लेन मोर. सिर्फ इतना है कि उस शार्प टर्न में डेरिवेटिव डज नॉट एक्सिस्ट, एंड डेरिवेटिव डज नॉट एक्सिस्ट इसलिए कि slope of the tangent does not exist, and slope of the tangent does not exist because there is no unique tangent. There are infinite number of tangents are at that point. That is why it does not exist. So differentiability implies continuity, but continuity generally does not implies differentiability. That means every differentiable function is continuous, but every continuous